So the problem states that you are in an island 2 miles from the nearest point P on a straight shoreline. 6 miles down the shoreline from point P is a restaurant at point R. To reach the restaurant, you must first row from the island to a point Q, averaging 4 miles per hour. You will then jog the remaining distance to point R, averaging 6 miles per hour. Now, this is a visual of what the problem states, with 2 miles from the island to the shoreline and the total shoreline being 6 miles. We can also add in the rates with 4 miles an hour to row and 6 miles an hour to jog. Now the first question wants us to write a function to model the time it will take you to reach the restaurant, R, as a function of the distance between R and the point you rode to, Q. Now before we start anything, we need to determine the independent and dependent variables. The independent variable is the input, or what you're going to be changing in the equation. And from the problem, we can see that it's the walking distance, which is from point Q to R, and for simplicity, we'll call that W. The dependent variable is the output of the equation, and that's the total time, which is walking plus rowing, and we'll call that T. Now, this is a diagram of the independent variable added in, W, and we can call the length from Q to the island R, which is the distance rowed. Now we need to determine some of the formulas that we're going to need to solve this equation. One of them being the Pythagorean theorem, a squared plus b squared equals c squared, in order to find the distance of R. The other is a time equation, where time equals distance divided by rate, because our total output is going to be time. Now if we know that W is from point Q to R and the total shoreline is 6 miles, we can determine that from point P to Q is 6 minus W, or the total minus W. And we're going to want to add W and R, well, the rates of those, in order to determine the total time it will take to get to the restaurant from the island. We can say that T of W equals W plus R. Now in doing this is just adding the distances, which will not give us the time in the end, but using the time equals distance divided by rate formula, we can change that so that T of W equals W divided by 6 plus R divided by 4, or the total distances of rowing and walking / jogging divided by their rates. Now R is not an input of the equation. W is the only input we have. So in order to find what R is, we have to put it in terms of W. In order to do this, we need to use the Pythagorean theorem, which will give us R squared equals 2 squared, which is the miles from the island to the shoreline, plus 6 minus W squared. And we're going to need to put that in terms of W, so we can put it in a function where W is the only input of the equation. So distributing these squares, we can say that R squared equals 4 plus, in parentheses, 36 minus 12W plus W squared, if you factor that out. Then you combine those two, so that R squared equals W squared minus 12W plus 40, and then take the square root of both sides to get R by itself, and you will get R equals the square root of W squared minus 12W plus 40. Now coming back to the diagram with point R in the final equation still, and using substitution, we can put that new equation in for R. So now W plus the substitution of R in terms of W equals the total time. And if we put that into the equation of T of W equals W divided by 6 plus R divided by 4, and if we substitute out the R for the new equation, or what R equals, we'll get T of W equals W divided by 6 plus the square root of W squared minus 12W plus 40 over 4. So now we can find the total time it will take to jog and row in terms of w, which is our independent variable, or the input. And this is the equation we can use to find the total time for the distance that you walk/jog.
Question B asks to find the minimum amount of time it will take you to reach the restaurant and how far from the restaurant will you need to row. As a reminder, our independent variable or walking distance is w, and the dependent variable or total time is t. To find the minimum amount of time it will take you to reach the restaurant and the distance from the restaurant you will need to row, we need to look back at the previous function, t of w equals w divided by 6 plus the square root of parentheses w squared minus 12w plus 40 parentheses divided by 4. To find this minimum amount of time and the distance, we need to revert to our calculators in order to calculate this specific amount of time and distance. Our variables in our calculator are going to be different from the variables in our function or equation. So in our equation, we use w as our independent variable or walking distance and t as our dependent variable or the total time. But in our calculator, we're going to use x and y. So y in our calculator is going to be equal to t, and x in our calculator is going to be represent w, which makes sense because x on a graph, x is the independent variable. It can stand on its own, whereas y depends on x on a graph. So making ty or total time depends on our distance. So total time would be y, which is the dependent variable, and w, which is the distance, which it can stand alone, would be x, which is our independent variable. So to exactly find the most accurate minimum amount of time and exact distance you need to row, we have to put our function t of w equals w divided by 6 plus the square root of w squared minus 12w plus 40 divided by 4 into our calculator. Basically, we have to graph this function, and our graphing will ensure the most accurate answer for the time and the distance we need. So to do that, we go to our graphing calculator and we obviously turn it on. So to graph a function on a calculator, you need to go to the y equals function. y1 or any of these y2, y3, y4, they're going to represent t of w in our equation, where t of w equals y, and the w in our equation, so the w divided by 6 plus the square root of w squared, all of these w's are going to be represented by x in our calculator. And w, once again, is our independent variable, and t is our dependent variable. So to do this in our calculator, we first need to do w divided by 6. I like to put parentheses, so I go to my parentheses key down here. I like to hit parentheses so my calculator knows the two parts of the equation and not like, so the calculator doesn't mix up those two parts of the equation. So I always make sure I put my parentheses around the parts that I want separated in my equation. So I go to this x, t, theta, n key, and I get x. Once again, x is going to represent w in this equation, and then I'm going to divide it by 6. And then I'm going to close my parentheses because that is one part of my equation. So then I'm going to add it. I'm going to do addition because for the second part, I'm going to do another parentheses to show the second part of my equation. And then to get the square root function on a calculator, you do second and then y squared, which is down here. And you get the square root function because the square root, the inverse of a square root is x squared. So it makes sense that it would be under that key. So the square root, and then I'm going to type in, once again, it's supposed to be w squared, but in this equation, x is going to represent w, and I'm going to do x, and then I'm going to go back down to where I got my square root and just hit x squared to square that x, and then I'm going to subtract 12, and once again it's supposed to be w, but x represents w, so I'm going to go back to my x key, and then I'm going to add 40 to that equation. Now, to finish off the square root, you have to hit key over, because after this I have to divide by 4, but I do not want my I don't want the divided by 4 to be under the square root symbol. I need the square root of this of x squared minus 12x plus 40, all of that divided by 4. So I have to go 1 over to finish my square root, and then I need to divide by 4. And then I need to close my parentheses because that is the end of that part. Now, since this function is going to be different, then each function is going to have, whether it's this equation or another equation, it's going to have various windows, so it's going to have different minimums and maximums, and it's going to, a lot of, like, graphs are going to be different if it's quadratic or linear. So to make sure that I can see my full graph, I need to fix my windows. To do that, I go to just windows at the top, which is right next to the y equals. So my minimum and maximum I'm going to change, as well as my x minimum, my x maximum, and I'm also going to change my y minimum and my y maximum to ensure when I do graph my function, I can see every single part of my graph. So if I just analyze my function and I look at the original numbers that I was given, so rowing is 4 miles per hour and jogging is 6 miles per hour, and then I have a 2-mile distance. So basically, by the numbers that I'm given, I'm just going to choose what I think our function would fit under, which window it would fit under. So I'm going to go to -2. Now, I can't have a -2 distance, but I want to see my full graph, and so it's smart to put your minimum at -2. And then I'm going to go up to, I could do 10, I could do 20, but I really want to see the full of my graph, so I'm going to do 60 and this x max. And then I'm going to go, the scale is fine, I'm going to go down to my y minimum. So my minimum obviously is not going to be a negative number, but it's really nice to see that on your graph, or have it represented on your graph, so you can see the full graph and really get that minimum that we're trying to find. And then for my y max, I'm going to go to like 35, something that's not so big, but it's still big enough that you can see it on your graph. Now that I have my windows fixed, I can finally graph my function. So I'm going to go to the graph key on my calculator, which is the last key to the right of my calculator. I'm just going to press get graph. So as you can see, my windows made it able for me to see that minimum. It's a very small, it's a very small curve, so I could have fixed my windows maybe a little bit more to make it very defined. But this will work for me as well, because I can see that to the left side, that line is going up, and to the right side, it's obviously going up as well. So my question, if I go back to my question, I'm being asked, find the minimum amount of time it will take you to reach the restaurant. So if W is representing X, I'm trying to find so W is the distance and T is the time. So I'm trying to find the total time in walking distance. So my time will be what's on the Y, and my X will be the distance. So to find a minimum on a graph, because I am trying to find the minimum amount of time, I need to find my minimum on this graph. So to find my minimum, I go to second trace, and it'll take me to value, 0, minimum, maximum, intersect, and some more things that we don't need. So to find my minimum, I obviously go to minimum, which was 3. So left bound, I need to go all the way to the left. This is going to take a while, but go all the way to my left. So I can just guess, and then I'm going to go right bound. So I'm trying to get it in between my what I believe my minimum is. I don't know the exact value, but I can guess it's somewhere in between these things, so I'm just going to guess right here. And then my calculator is going to give me my minimum. So it's saying my minimum x value is 4.21, and then my minimum y value is 1.37. If I go back to my equation, which is T of w equals w divided by 6 plus the square root of w squared minus 12w plus 40 divided by 4. I said that my w and w represents my independent variable, or the distance. W equals x. So my x value on this calculator is going to be the minimum distance. Now for y, I said the dependent variable, or the total time, is t. So T of w in my equation was y equals. So my minimum time is going to be whatever y equals. So on the calculator, my minimum distance is going to be 4.2. And if I go back to my rates are in miles per hour. So my distance is going to be 4.21, or around 4.21 miles. And then my time, so how far from the restaurant will you need to row, that minimum amount of time is going to be whatever my y is, and it's in hours, so it's going to be 1.37 hours. To sum up our findings, the minimum amount of time it will take you to reach the restaurant will be 4.21 miles, and the time you'll need to row from the restaurant will be 1.4 hours.
And now for our third question. How long will it take you to reach the restaurant if you only want to jog half of a mile? In the diagram, it shows that our walking distance is half of a mile. Using our equation that we found in the first problem, we can find the time it will take if you only want to walk 1/2 mile. Starting with our equation, we must substitute the walking distance, or w, for 1/2. Substituting 1/2 into our equation, we now have the equation 1/2 divided by 6 plus the square root of 1/2 squared minus 12 times 1/2 plus 40, all divided by 4. Now simplifying it down, we can find that our time is equal to 1.5464 hours. Converting that, we can find that it will take us 1 hour and 32.4 minutes to reach the restaurant if we only want to jog 1/2 mile.